Okay, this is Geometry Section 6.2, and the name of it is Parallelograms. So we're just going to go through what parallelograms are. We'll start with the definition. This is on page 433, so you can follow along on 433. And a parallelogram is a quadrilateral with both pairs of opposite sides parallel. This is a definition of a parallelogram. Quadrilateral means that it has four sides and both pairs of opposite sides are parallel. Not one pair, but both sides. Okay? We use parallelograms so much that we actually created a symbol for parallelograms. If you look here, I have a parallelogram drawn with the opposite sides parallel, and here is the symbol that we use for a parallelogram, A, B, C, D. So it's like the triangle symbol. We use it accordingly. So you need to know how to spell parallelogram, P-A-R-A-L-L-E-L-O-G-R-A-M. However, when we're just using it in assignment things, you can use the symbol. But if you ever write it on a test or a quiz, it must be spelled correctly. Okay? So do you understand that this is the definition of a parallelogram? It is not a theorem. It is the definition. So if we ever use it in a proof, we would say definition of a parallelogram. Okay? All right. Now, there's some theorems then that come from a parallelogram. The first one is the opposite sides of a parallelogram are congruent. Okay? Opposite sides of a parallelogram are congruent. I'll go through these a couple times because I'm going to draw a picture here when I get through most of them. And then we'll mark it the way it is. Not only are opposite sides of a parallelogram congruent, opposite angles of a parallelogram are congruent. Okay? So if I draw a parallelogram, I'll just go ahead and start to draw it here. We know that the opposite sides are parallel. We also know that now the opposite sides are congruent. That means that this side has a mark and this side has a mark. This side has a double mark and this side has a double mark. And I can switch those marks around. It does not matter. Oh, I got the wrong lights off, don't I? Oh, I know why it's backwards. Depends on that one over there. Okay. All right. Much better on the screen anyway. Okay, then the opposite angles, that means that this angle is congruent to that angle. And this angle is congruent to this angle. And they are not congruent themselves. In other words, unless they're right, this one does not equal this one. Okay? But tell me about this one and this one. These are called opposite angles. These are called consecutive angles. One right after another. What about these two and these two and these two? Do you know of anything that's true about it? Well, we're going to get to that. Consecutive angles of a parallelogram are supplementary. That means that this one and this one add up to 80 degrees. It means that this one and this one add up to 80 degrees, and this one add up to 80 degrees. And likewise here. Does that make sense? So if this one is 120, this is 60, correct? Making this 120 and this 60. Okay? So once you have one, you can find all the rest of them. All right, now it says if a parallelogram has one right angle, it has to have four right angles. So one right angle would look like this. Once it has one, since these two are consecutive, they're supplementary, so it has to be 90 also. The opposite of both of those then would be 90 because they're equal. So based on these theorems here makes this one happen. Okay? So if a quadrilateral has one right angle, it becomes a rectangle. Okay? Excuse me. If a parallelogram has one right angle, then it becomes a rectangle. Okay? the diagonals of a parallelogram bisect each other. And I'm going to show you this. I'll go ahead and give you the next one too. It says each diagonal of a parallelogram separates the parallelogram into two equal triangles. We're going to talk about both of these right here. Okay, now you'll notice that I drew separate pictures because it's kind of hard to see all of this marked on the same parallelogram. But if I just draw one diagonal, this is what a diagonal is. A diagonal is a line segment, if you remember before, a line segment that that joins two non-consecutive sides. There are two diagonals in a parallelogram. There's this one, and this is the longer one, right? This is the longer one, and notice that it connects the two acute angles, right? And then there's this one here, and I'm not going to draw it right yet, okay? Both diagonals, it doesn't matter which one, separate these into two triangles. This one, these two triangles are congruent because this side is equal to this side is equal to this side, and they share this side. So by SSS postulate, these two triangles are congruent. You understand that? Okay, so what I'm going to do is I'm going to erase this one, and I'm going to draw the other one. Now you can tell that one is definitely shorter than the other one, correct? All right. Diagonal, they're diagonals of a rectangle. Excuse me. Diagonals of a parallelogram are not congruent unless it's a rectangle. Okay. But see, you can say now this triangle is congruent to this triangle because this side is congruent to this side is congruent to that side, and this side they share. So by the SSS postulate, once again, these two triangles are congruent. But you notice that they're two different triangles compared to the last two triangles, right? Now, if I draw both of them in, like this, okay? This theorem right here, this one right here says that the diagonals bisect each other. That means that this, guys, is congruent to this. And this is congruent to this. Do you understand that? Questions? All right, good. Because now I'm going to have a few problems here you need to look at. All right, let's take a look at this. I'm going to tell you that this is a parallelogram. Okay, this is a parallelogram. This side is 4x. This side is 18. This side is 8y. This side is 7y plus 3. This angle is 2z degrees. This is 18 degrees, and that's 40 degrees. What I'm challenging you to do is to find x and y and z. Okay? Make sure that you have an explanation on how to find them, please.
Does it say 18 degrees?
18 degrees, yes, and 40 degrees.
Is that 7y plus 3?
Yes. This is 2z degrees. I put it in parentheses because it was an angle, correct? Okay, so let's talk about how to find x. How do you find x? Connor? 4x equals what? 18. Because opposite sides, that theorem, opposite sides of a parallelogram are congruent. So if I divide both sides by 4, I get what? X equals what? 4.5. Okay? You okay with that, Dylan?
Yep.
All right. So now how do I find y, Nelcha?
40 plus 18.
Y? No.
Oh, okay.
Y is here and here.
Oh. 7x plus 3
How about 7y plus 3?
equals 8y.
Okay, and that theorem is because the diagonals bisect each other, right, Kagan? Alright, so I'm going to subtract 7y from both sides, and I get 3 equals y. Is that correct? Alright, and how do I find z, Kellen?
2z equals 58.
What is it?
58
I don't think so.
is 40 plus 18.
Nope, because 2z is only this angle here.
40.
Nope. Anybody want to take another guess?
18.
18. And here's why. Listen very carefully because you're going to have this on the test. See this line right here? Parallel to this line, correct? This right here, my fast furry friends, is called a transversal. So this angle and this angle are alternate interior angles. Just like this angle and this angle are alternate interior angles. And alternate interior angles of parallel lines are congruent. So z equals 9, correct? All right. And we don't have to put degrees on that because it is part of the big picture, isn't it? Okay? Questions? All right. Okay, so here's another parallelogram. I'm telling you that it's a parallelogram. Notice I didn't mark either one of them as parallelogram. I would have to mark the opposite sides parallel if I did that. But what I did was I told you that they were parallelograms. So now I want you to solve for x and y. Okay? This is 4x degrees. This is 2x minus 6 degrees. This is y plus 8, and this is 5y. So if you'll solve for x and y, we'll talk about that. Okay? How do I solve for x?
Is it 4x plus 2x minus 6 equals 180?
That is correct. They are supplementary. Okay? So if I change that, it'd be 6x plus a negative 6 equals 180. And then I subtract a negative 6, which is the same as adding 6, right? So what I get is 6x equals 186. And so x equals what? 31. Once again, x is a value, so I don't have to put degrees on it. If I asked you to find the whole angle, then you would put degrees on it. Correct, Dylan?
Yeah.
Okay. All right, so how would I find y? Yes, Nelson.
5y equals y plus 8.
That's right. That's the easier of the two, isn't it? And if I subtract y from both sides, I get 4y equals 8, and then y equals 2. Any questions on that? Okay, I'm going to erase this. Do you got it all? All right. We're going to do one more problem. The diagonals bisect each other, right? So where do they intersect at? If the diagonals bisect each other, let's take a look at this. If the diagonals bisect each other, like this one right here, what's this point? It's, okay, you're close. It's the midpoint, isn't it? In other words, it's a midpoint between this point here and this point here, correct? Now, there's a reason I'm telling you this. There's a reason we're talking about this, okay? Just keep this in mind. And also here and here, okay? All right. So I want you to turn to page 436, and do not have this one drawn. We're going to work on this one together. This is example 3. I'll read it to you. It says, determine the coordinates of the intersection of the diagonals of parallelogram FGHJ with vertices F, -2, 4, G, 3, 5, H2, -3, and J, -3, -4, correct? Well, I don't need a coordinate plane to do this. What I want to show you is we got a parallelogram, correct?
Yeah.
All right, I'm just going to draw. I'm not going to draw it the way it's supposed to be. Told me it's a parallelogram. I can start at any corner I want, okay? I can start at any corner I want. I'm going to start right here. I'm going to call this F. Now, once I name that one, I just go in clockwise, and I just name the other points. So this is F, G, and this is H, and this is I. So my diagonals, right? My diagonals are FH, and that's a length, or I can put it, I'll just say FH and GI, correct? Right? Okay. What we learned from the last picture was that the diagonals meet in the midpoint of FH and the midpoint of GI. So all I have to do is find the midpoint. Do you remember how to find the midpoint?
It's like, x sub 1 minus
It's actually plus
over 2.
over 2. There you go. And then y sub 1 plus y sub 2 over 2. This point here is the midpoint. Now, which one do I find? Does it matter? Will it be the same for each one? Yes. So if half of you chose, why don't Kagan, Nelcha, and Connor, why don't you do FH, the midpoint FH, and then you other three do the midpoint of GI, okay? So I'm going to just choose one. I'll just do GI. So I've got to take the coordinates of G and I. So G is 3, 5, and I is, it's J actually in the book. We'll call it I, okay? I'm sorry, it's J in the book, okay? Do I need to change that, or you? Okay, you know what you're doing, okay. So then I have 3 plus a -3 divided by 2 and 5 plus 4 divided by 2. Did you get that?
Yeah.
0, 1, half, and it doesn't matter which two you choose, you get the same thing, don't you? Connor? Okay. Okay. And he worked on the other two, didn't he? Okay, so that tells you. Okay. All right, there's one last thing we want to go over, and this is an overview, and I thought about starting with this, but I didn't know how much time it would take to go over that other stuff. I want to make sure that I got the other stuff. But I want you to look at the family of quadrilaterals, okay? This is the family of quadrilaterals. There is no symbol for quadrilateral. It's just, okay? Quadrilaterals are four-sided figures, okay? But I want you to have this in the back of your head when we start talking about these. Okay, we start with we start with a four-sided figure, okay? That's called a quadrilateral, correct? He's the top dog. All right. From this quadrilateral, we come over here, and we're going to talk about a four-sided figure that looks like this. Okay, and this is called a kite. Okay, and it's a quadrilateral. I'm going to abbreviate quadrilateral. It's a quadrilateral with consecutive sides equal, congruent. Okay, that means, guys, that this side is congruent to this side and this side is congruent to that side. Okay, and since we are the kite capital of Nebraska, you probably should know this, correct? All right. Kagan, do you have any questions? Okay. All right, the next set that we're going to deal with is this guy. Anybody know the name of this guy? Trapezoid. It's T-R-A-P, and it actually has an E there, and then zoid. Trapezoid. The E is like an I instead of an E. Trapezoid. Okay? A trapezoid is a quadrilateral. Once again, I'm abbreviating quadrilateral with exactly one pair of opposite sides parallel. So trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Why not two sides parallel? That would be a what? That would be a parallelogram. Remember the definition of a parallelogram says both pairs of opposite sides are parallel? You remember that? Okay. Now, from this guy, there's this one. And this is called an isosceles trapezoid. Why do you think it's called an isosceles trapezoid? Actually, two of the sides are equal. This side and this side, and those are called legs. So it is and we'll go in more in detail as we go on, but an isosceles trapezoid has the legs equal. Okay? I'm just trying to give you an overview. All right, finally, we have this side, and this is the one that we've been talking about, and this is this guy right here, and you just learned about him. He's called the what? He's called a parallelogram. Okay, and I'm not going to put the definition of a parallelogram up there because you already have it, right? But a parallelogram, it's the only one that has a symbol. So that's how important it is. Most people think the rectangle and the square are more important. That's not true. A parallelogram is probably the bigger family. Okay, you understand that all four of these figures have four sides. So that's why that makes them a quadrilateral. Why did I put this guy under this guy? Because he has all the characteristics of a trapezoid, only we add that his legs are equal. You understand what I'm saying? So if something's underneath it, it has all the characteristics of the one above it, correct? Okay. Well, now, folks, the parallelogram can be broken up into two areas. The first one is this guy. He looks like this, and he has all sides equal. Do you know what he's called? Okay. He's called a rhombus, not a square. And it is a parallelogram. Notice he's a parallelogram, so he has all the characteristics of a parallelogram, which means what? His opposite sides are parallel, his opposite sides are congruent, his opposite angles are congruent, his diagonals bisect each other. If you cut one diagonal, it creates two congruent triangles. He has all the characteristics of a parallelogram, plus he has equal sides. Okay? And over here is this guy. What do we know about this guy? The rectangle. And even though the rectangle is not the big dog, his daddy is the parallelogram, everybody knows a rectangle. A rectangle is a parallelogram with 4 right angles. I forgot to put this one, parallelogram with congruent sides. Sorry, got to talking about it, got so excited. So it means that the rectangle has all the characteristics of a parallelogram. That means its opposite sides are parallel, its opposite sides are congruent, its opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, one diagonal separates it into 2 triangles that are congruent, plus it has 4 right angles. Okay? Now, if you put these 2 bad boys together and they have a little child, the square. Sides are congruent, angles are right. The square. By the way, square is S-Q-U-A-R-E. I have a lot of people that forget the E on the end of it. A square has all the characteristics of a parallelogram. It has all the characteristics of a rhombus. It has all the characteristics of a rectangle. So it is basically a parallelogram with 4 congruent sides and 4 right angles. He is like the superhero of the quadrilaterals. He's the perfect child. We shall call him Kellen. The perfect child. Is that true, Kellen? Okay. All right. You got it? Okay, that gives you an overview. So when we're talking about these things, I really want you to place these things where they belong. Oh, I know that you can say, oh, this belongs to this family, blah, blah, blah. Okay? All right, your assignment is, I'll put it down here, is I'm going to have Nell should put it on the board. It's page 437, numbers 9 through 24. Okay? 9 through 24. Page 437, 9 through 24. It is due Thursday. All right, it is due Thursday. You got lucky on that one. I thought about having it due tomorrow since you left off. All right. Good luck.